In this video, we're going to do a quick review of how to simplify imaginary roots. So, to remind you, the square root of -1 does exist. We used to say that you can't do it, but then we discovered that it exists in a different number system, and it's defined as I. It's the basic imaginary unit. Now, if you would square both sides, what would you get? Well, the squaring and the square root sign would just undo each other, so we know that I squared is equal to -1. Sometimes that pops up. Now let's look at what we do when we're simplifying perfect squares. Well, we know the square root of 1 is 1, the principal root. So the square root of -1 is I. The square root of 4 is 2, so the square root of -4 is 2I. The square root of 9 is 3, so the square root of -9 is 3I. The square root of 16 is 4, so the square root of -16 is 4I. Hopefully you see that pattern. So how do we handle it when we have an irrational radicand like 24? So the square root of -24 is equivalent to -1 times 24. And I'm going to break down 24 into my primes. So that's 4 times 6, 2 and 2, and their prime, and 2 and 3. So I know that the square root of -1 is I, so that's going to come out front. And I have a pair of 2's, so I can take the square root of that. So a 2 is going to come out to the front. And 2 times 3, well, I have no pairs, so they go back underneath the radical sign. So my final answer is 2I times the square root of 6. Or you can also write this as 2 root 6I. Just make sure that the I is not underneath the radical sign. Let's look at -3 times the square root of -75. Okay. So I'm going to break down this 75 into 3 and 25. Oops, and I wrote 7. Make that 25. And 25 breaks into 5 times 5. Okay, so I'm going to recopy the -3 that was out front. I have -75, which is the same as -1 times 75. And I know the square root of -1 is I. And then I have a pair of 5's, so I'm going to have 1 5 comes out front and a 3 left over inside. So this is -15I root 3. Or, again, I'll accept it as -15 root 3 with the I at the end. Okay, now this one's a complex number. Let me remind you that sometimes numbers are partially real, so 5 is real, and partially in the imaginary system. So together they're called complex. Right? It doesn't get more complicated than part real and part imaginary. So let's look at square root of -100. So my hint is when you do this, just completely ignore this 5 plus that's outside. So I'm just going to erase it for a second. And the square root of -100 is 10I. And now I'm going to put that 5 plus that was back there. Now, what's 5 plus 10I? Well, they're not like terms, so that's all it is. It's just 5 plus 10I. All right, the final one, 6 minus 3 times the square root of -18. Well, again, this 6 and this -3, I'm just going to recopy that at first. Don't combine them because they're not like. It's held to a square root. Now, 18 breaks into 9 times 2. 9 is 3 times 3. All right, the fact that it was negative, I'm going to have an I that comes out front. I'm going to have a pair of 3's, so one of them comes out front when I take the square root, and the 2 stays inside. So what I actually have here is 6 minus 3 times 3 is 9I times the square root of 2. You'll also see this written as 6 minus 9 root 2 with the I last, because by definition, a complex number has the I last, but I'll accept it either way. Okay, hopefully that's a good quick review on how you simplify square roots involving negative values.